Okay, so I can see that a lot of you are either done or getting real close. So just give you another moment here to wrap up, make sure we're doing good. While you're doing that, just a thought. Today's Wednesday, right?
Yes, sir.
So Thursday, tomorrow, we're going to be spending our whole class reviewing for our Unit 1 test. It'll be all of our class tomorrow, and then Friday is the Unit 1 test. So then as far as the DMR goes, we'll keep practicing this DMR into next week, and then we'll have our DMR for this at the end of next week. So you get a little extra practice with this stuff. Doc, your question?
You answered it with the DMR.
Fantastic. Okay, so why don't I unfreeze this and y'all can see my answers, and we can see if we agree or disagree. So for the first one, I got a final value of 3, so on and so forth. Issa, your question?
For number 3, I just put it
Yeah,
in a mixed number. Does
totally
that work?
fine. I prefer what I have up there,
Okay.
but yours is numerically totally great.
Okay.
No problems. Sophia,
How did you get number 3?
how did I get number 3?
Yeah, I'm kind of confused.
Is it okay if I just erase all that and just kind of go through my steps? You good with that? Okay. So before we even think about solving an equation, because you can see the instructions say solve, before I think about solving, I need to simplify. And I can see that on the right side there's not really much simplifying to be done, but on the left side there is. So if I were to draw my little fence down the middle here, I'm talking about to the left side of that fence. Do you see the 2x minus the parentheses? What that means is I am not just subtracting 5x, I'm not just subtracting 8, I'm subtracting everything in those parentheses, right? So the way that I think about this is almost like a distributive property. I'm going to subtract the 5x and subtract the positive 8. So because of that, my next step would be 2x minus 5x minus 8 equals the right side. Does that make sense so far? So again, like I said before, if you're going to be solving something, you want to make sure that you've got it as simplified as you can before you start getting into this whole solving stuff. So do you see how on the left side there's another little small simplification we could do? There's some like terms, right? Like right there and right there. So 2x minus 5x is negative 3x. And now at this point I feel like I pretty much have this simplified. And now I'm ready to try to solve it. The only issue here I see is that I've got an x on the left side of the fence, and I've got another x on the right side of the fence. Any ideas, Sophia, on how I could get those together?
You could add negative 3x to 7.
Say it one more time. I could add.
Add negative 3x to 7.
I actually don't want to add negative 3x.
Oh,
Yeah,
then you
because
just
you-
add.
7x to 3x.
Well, no, we're kind of like zigging and zagging here in the wrong way. If I want to move the negative 3x, what I would do is this.
Add 3x.
I would add 3x. Okay? If I wanted to do what Mason was suggesting, I would not add 7x to both sides. What would I do?
Subtract.
I would subtract 7x from both sides. So you could go either way. It really doesn't make a difference. In the end, we should all get the same answer. Sophia, since you suggested it, I'll go with plus 3x to both sides. But I think in my original solution, I did it the other way. But we should get the same thing. So if I do this, what's negative 3x plus 3x?
0.
0. And that was the whole goal, right? It was to get it off to that side. So I just end up with 0 minus 8, which is negative 8. And on the right side, 7x plus 3x. 10x. There we go. So 10x plus 11. And now we're down to kind of that hopefully more familiar setup, right? Would you get rid of the 11 first or the 10?
The 11.
That's right. And how would you get rid of the 11?
You subtract it.
There we go. So if I do that, I end up with negative 19 equals 10x. And then how do I get rid of the 10?
You divide it.
There's your division. That's right. So divide by 10, and you can see we're going to get that negative 19 tenths for our one solution. Is that a good enough explanation?
Yeah.
Okay, awesome. Thanks for asking. What else can I do to help any of you? Hopefully we can work through it, but whatever, let me know. How you guys doing with the function stuff for number 4?
Good.
Domain and range, okay. Choosing whether it is or is not a function. What about the explanation? I put up there the input 5 has 2 outputs. I would make sure that you understand why that is. If you look at it and you're like, input, schminput, output, well, what? I don't even know what you're talking about. Like, that would not be a good place to be, right? I'd want you to say, what is an input? We can talk about that. I
You
don't know.
have to say the specific numbers that has
Um,
2 inputs.
I would always try to be as specific as possible. Here, I put the input 5 has 2 outputs. It might have been good. I kind of got tired of writing with my finger. It might have been good for me to say, the 5's outputs are -9 and 2.
Okay.
I think that would be a good practice to do for sure. Anybody else? Maybe a question or any kind of concern? Okay. So we're gonna get a little bit into graphing today. I've got all the graphing paper you might possibly need for this today in your packet, so there's no need to get any additional graphing paper. But before we do move on to that, I do want to mention again, tomorrow is going to be our full review day from minute 1 till the end. We're just going to be reviewing for your Unit 1 test. And I think a really excellent thing for you to have with you tomorrow would be some sort of an internet device, like a phone or a computer, so that you can be very productive. So please don't show up tomorrow without a device unless you don't have one, and then we'll figure out a way for you to get one, okay? Make sense?
Mm-hmm.
Cool. All right, so let's move forward into graphing. Anybody ever graphed lines before? Some? Yeah, I'm seeing a few hands up. All right, that's good. So let's talk about a couple of basics here. We'll get into some graphing. We'll spend a lot of time on graphing. It's not going to just be a today thing. It'll be a today and then all of next week. And we'll spend a lot of time hopefully getting you very good at graphing. This could be one of those things where you're going to want to be really proactive. If I say something and you're confused, like, why is that thing where it is? Let's talk. Let's talk and hash it out, okay? Okay. What is a linear equation? What is a linear equation? I'll write it up here for you. It is any equation of this form, ax plus by equals c. So some things to notice here. What's the exponent on the x? No, a is the coefficient. It's x to the what? First. Yep, so if it's ax to the first, what's the exponent on the y? First. So if you have a couple of variables, x and y, and they're both to the first power in an equation, it'll always be called a linear equation. And if you graphed it, the shape would be a straight line. A straight line. Don't get too hung up on the ax plus by equals c. You're going to see a ton of that. I think you'll get real familiar with that quickly.
So at my old school, we learned, is it the same thing as like mx plus b?
So this can easily be transformed into y equals mx plus b. So this is a very generic form. This is a very specific form. And we'll actually look at another form of lines. It's actually, in my opinion, Sophia, is even better in some cases than that y equals mx plus b thing. Sometimes that's better. But I'll show you one that's real good as well.
So the linear equation is a straight line on a graph.
On a graph, it'll always be a straight line. So later on this year, and for sure when you get into Algebra 2, you'll start to see relationships in which the graph is not a straight line. It'll have curves to it, right? It'll go up, then down, and maybe up and down several times. So not everything is a line, but we're going to be focusing on lines right here. Okay, so the points on a graph of a line, this is a really important concept. The points on the graph of a line stand for values that make the linear equation true. So let me give you an example. I've got this lovely linear equation right here, and then I've got its graph over here. Can anybody find any points on that graph that are actually on the line? What would be a suggestion? What do you see?
The 3?
So remember, points on a line, points on a graph are always going to be something, comma, something. Right? It's going to be an x, comma, y. Mason, what do you see that's actually on the line?
1,3.
So here's 1 right here. So I think 1, comma 3 is right there. So I don't think that 1, comma 3 is actually on our line. Looking for a point that's actually right on the line. What do you see?
0, 3.
Okay, let's see if that works. So 0, 3, that means go left and right 0, up 3. Would you all agree that that point is right there?
Yeah.
So 0, 3, hopefully we can agree that that is on the line. Now that should make the equation true. Let's check it out. The y is 3, and the x is 0. What's negative 2 times 0?
0.
So 3 equals 0 plus 3. Look, it's true. What if I picked that point that was mentioned earlier? What if I picked 1, 3? Should this make the equation true?
No.
Let's find out. So this would be y is 3, x is 1. What's negative 2 times 1? Plus 3?
1.
Positive 1. That's supposed to be 1. Does 3 equal 1?
No.
Oh, this is false. But that should make sense because didn't I pick a point that's not actually on the line? So if I were to pick any other point on the line, can anybody find maybe another really easy point to work with? What do you see, Bree?
1.50.
I think there's an easier one. I think that is on the line. Let's find, that's actually not a bad one. Let's go with that one. So she's pointing out this one right here. 1.5, 0. If I were to plug that in, y is 0. And then x is 1.5. What is negative 2 times 1.5? Not negative 30. Negative 3. And what's negative 3 plus 3?
0.
It's true, because she picked a point on the line. Do you see how it's producing a truth?
Yes. Or 0 is true?
0 is 0 equal to 0?
Yeah.
Yeah. So sometimes we see zeros in an equation, and correct me if I'm wrong, but we sort of freak out a little bit. We're like, oh my gosh, there's a 0. It's okay. 0 is just a number, and 0 really does equal 0, so it works. So all I'm trying to prove to you here is that if you pick any point that's on the graph of a line, that point will make the equation true. If you pick a point that's not on the line, it'll make the equation false. Does that make sense? Okay. So then maybe the next question would be, how on earth do we come up with these graphs? So there's lots of ways. Here is one of them. Look at practice 1. Now remember, the points on a line will always make the equation true. And so one of the ways we can graph a line is to create a table of values or a table of solutions. So this is kind of have you ever heard of like input, output in math, like with functions? We've talked about that a little bit. Let me do one of these for you. Here is my set of x values. You'll remember in function notation, what do the x's go with? Do the x's go with your range or do they go with your domain?
Domain.
They go with your domain. So I've given you a domain here. The domain is -5, 2, 0, and 3. And what we're supposed to figure out is what's the range. Here's how we do it. I'm going to take my first domain member, and I'm just going to, you said it, I'm just going to plug it in. So it would look like this. Y equals 2 times 5 plus 1. I follow order of operations. What's 2 times 5
Isn't it,
plus 1?
is it not negative? Negative 9.
Oh my goodness. I plugged in a 5. I meant to plug in a -5. I'm going to blame that on my finger. Okay, what's 2 times -5 plus 1?
9.
Not 9. There's our -9. Yep. Okay, so what I want you guys to take away from this is this. This column right here that I'm highlighting in green, the fact that x is -5 and y is -9, that means the point -5, -9 is on my line. So I turn to the graph and I try to find this. Oliver, what does -5, -9 mean? Like, it's giving me some directions, right?
Where is on the...
And so what do I do? Like, what does negative 5 mean in this case?
5 columns over to the left.
5 to the left, and then what about the negative 9?
9 down.
Yep. So did you guys put this point right here? Please look. You see my blue point up there? Is that where you put negative 5, negative 9? All right. How do I find a second point?
Plug it in.
Plug what in? Negative 2. There you go. So if I plug in a negative 2, I get y equals 2 times negative 2 plus 1. So I got to follow PEMDAS again. If I do follow PEMDAS, what do I get? Negative 3. Good. So that goes here. And doesn't that mean the point negative 2, negative 3 is on my line? Is this making sense? Bray, what does negative 2, comma, negative 3 mean on my graph?
Sorry, what?
When I see this negative 2, negative 3, what do I do with that on the graph?
You go to negative 2.
Which, but there's two of them, right? There's a negative 2 down, and there's one to the left.
It's the one down.
It's actually the other way around.
Oh, the one to the left, and then negative 3 is the one down.
Yep. So would it be fair to say that negative 2, comma, negative 3 means left 2, down 3?
Yes.
Okay. So I'm going to go, start at the origin. I go left 2, down 3. Oops. Left 2, down 3. Is that okay? Well, I missed it. How about that? Good? Okay. How about the 0? Have you guys already done the 0? We plug this in. Y equals 2 times 0 plus 1. What's the output?
1.
The output is 1. So, Doc, when I see a 0 and a 1 in my table, what does that mean for my graphing?
What?
So when I see this, I input a 0 and my output was a 1. What does that mean on my graph?
That it's not true? Or that it's...
No. No, we're not looking to see if something is true or false. What I did is I saw that 0 was my input. And so I plugged it in right there. And what did I get out? What's 2 times 0 plus 1?
1.
1. Okay, so on my graph, that 0 and that 1 have meaning, don't they? What do they mean? Drawing a blank?
Yeah.
Sebastian, what do you think? Listen now, listen.
You don't go left or right. You stay at 0 and you go up 1.
Because isn't this the point 0, comma 1?
Yeah.
You described it really well. He says you don't go left or right because of the 0. And because of the 1, you go up 1. Does that make sense? Okay. Okay. So 0, 1 is right about there. What is this starting to look like?
A line.
Do you see the pattern? It's looking pretty straight line-ish, right? How about the last one? Ellie, did you plug in a 3?
I got 7.
Let's find out. So y equals 2 times 3 plus 1. Order of ops would be 6 plus 1. 7 makes a lot of sense. Okay. So Doc, I'm going to come back to you. When you see the input was 3 and the output was 7, what does that mean on my graph?
You go to the right 3 spaces, and then you go up 7.
That's right. So 3 comma 7 means exactly what you just described. So let's see if I can get there. How about right there? Oh, come on. Right about there. That's looking pretty linear, isn't it?
Yes.
Pretty much of a straight line. So what you then want to do is connect those with as straight of a line as you can. I'm going to do my best. That's pretty close, I guess. Put little arrows on the end. What do the arrows stand for? That's right. It's not a line segment. It just goes on forever, either direction. We've got our lovely line right there. How you feeling about this? Great. Good. Any questions? Great, good, and really good. All right. It could be going bad. It's not? Okay. Let's see what's left here. We'll wrap things up here in a couple of minutes. Let's see here. Let's do this. This will be a nice way to wrap this one up. Number 3, I think, would be really good. So let's focus on this. We're going to do our functions concept quiz here at the end, but we won't need a ton of time for that. Okay, go. There it is. So you've got a linear equation, 2y plus x equals 8. The first instructions are solve for y. So let's see if you guys can get the y all by itself first. For part A, all it is solve for y. Get the y by itself, and then we'll create our little table and try to create our graph from that. Remember, the points on the graph of the line make the equation true. Sir? I would, yeah, because we're trying to get the y by itself. That would be my first move.
This doesn't have x, so
Yeah.
what would you be subtracting? Would you do it like this?
So they would just be unlike terms. No. We're not solving for x, actually. We're solving for y. It looks like, Doc, you're trying to get the x by itself.
Yeah. So how to do that?
You guys need some help with this?
Yeah.
Let me show you. I'm getting quite a few questions. So the first thing that you'd want to do here is identify that you're trying to get the y by itself. And I kind of like the little fence graphic here. Can you see how on the left side of the fence the y is obviously not yet by itself?
Yes.
What are the two things that are with the y over there? There's a 2 and an x. Do you see how it's 2 times y?
Yes.
And it's plus x? So there's a very consistent pattern that we will follow here. Do you guys think that we should get rid of the 2 times whatever, or should we get rid of the plus x first? Which one should we deal with first? No, we actually have to deal with the plus x first. I think this makes the most sense. So I've got plus x. How would I take that plus x and get it over to the other side of the fence? Subtraction. So I'm just going to go minus x. And I was talking to Sebastian about this a second ago, and he said, his question was basically, how do I deal with the 8 minus x? And he said, because they're not like terms. He's totally right, isn't he? Because the 8 and the minus x are not like terms, what's the result of 8 minus x? It's just 8 minus x. Yeah, we don't get too fancy with that. We just say, yeah, we can't add those or subtract those. We just end up with 8 minus x. Okay. Then we still have the 2. We decided we were going to handle that last. And we do what?
Divide.
We divide by 2 on both sides. And we get this. Here is where there's a variety of things you could do with this. If you just wanted to leave it as is, y equals 8 minus x over 2. You're welcome to do that. Remember how we talked about splitting it up? This would be a place where I'd want you to start thinking about going y equals, what's 8 divided by 2?
4.
And then x over 2 is just 1/2 x. I personally like that better, but I would take either one of those, really, in most situations. Moving forward, we want to start thinking about that second version, though. You remember doing this before? We did almost this exact same question once before. So anyways, so let's create a table. This is where we get to make our own table. How many points do we need to graph a line? You need a minimum of 2, right? And so if you can come up with 2 points, you should be able to graph the line. We get to actually pick our domain here. So I'm going to let you pick. What do you think would be a really smart strategic number to choose as an input? 2 would be very smart. Let's use that. So if I picked out a 2, I'll just come off to the side and we'll take our equation. Wouldn't it be y equals 4 minus 1/2? Ellie, I gotta ask, why on earth did you pick 2? It is a good number. Yeah, and especially times 1/2, right? What's half of 2? 1. And so what's our output?
1.
No, our output's not 1. It's 4 minus 1, right?
3.
So it'd be 2 for an input, 3 for an output. So that means my point is 2, 3. That was really smart. I like that. I think there's one input that's even a little bit better. Bree, what do you think?
2.
We already said 2.
4.
I think I would say 4 is similarly smart to what she said. I actually think 1 is not my favorite. There's one that I think would be even more of a favorite. 4 is smart, but I think there's a better one. 0. 0 is often a really nice input. We sometimes get a little bit scared of 0, but check this out. If I make my x 0, I come over here and say, all right, y equals 4 minus 1/2 times 0. Based on all what you understand about your properties, what's 1/2 times 0? And what's 4 minus 0? That 0 actually make this one sort of easy, right?
4.
So you get a 4 for an output, yeah. So that means the point 0, comma 4 is also on my line. And I could do more points if I want, but this would be enough
To make a line.
to make a line. Yeah, 2 comma 3 is up here. Where's 0 comma 4? What does that mean? Any suggestions?
Straight up.
Just straight up.
Yeah, straight up 4. Yeah, so right about there. And then I would do my best to connect these. That did not go well. Almost. There we go. I got a nice line that looks about like that. Yes, ma'am.
Couldn't you, like, technically, once you get this,
Oh, yeah, you could do
just-
slope intercept form. Yep. Can you see the awesome slope intercept already? Yeah, so we'll get to slope intercept. We'll also get something called point slope. There's a lot of different ways to handle these, and that's what you're suggesting is one of them, for sure. For sure. Okay. If you don't feel like you have lines mastered yet, that's okay. We're going to spend like all of next week on these, so don't stress too much. Okay, we'll keep at it. So if you guys would clear your desks off, grab some fort building materials, build a little fort.